In this practice, we're going to take a look at some table problems, some free response questions that involve tables. All right, so functions and their derivatives can be represented as equations, graphs, and tables, and we'll be ready to analyze in all these different forms to use functions and integrate and find derivatives and things. Okay, so in these table problems, that's what I'm going to call. It's not an official name there. We'll be connecting these derivatives and integral properties to finite values of the function. So certain values of the function that gives us an idea of what's going on with the function, but we don't know the entire function. So some things to kind of be aware of, okay, things to think about, that usually these points represent points of a continuous differentiable function, all right? So we're going to get a table here. We're going to see a table, something like this. Here's a table of some function g of x and g prime of x, okay? So keep in mind that this comes from some function g of x, okay? And, these are just giving us some values. It's telling us, when what do we got? When x is -5, y is 10 up here. When x is -4, y is 5. -3, 2. I'm just kind of guessing here. -2, 3, -1, 1, and 0, 0. It's not a 45. I didn't draw that very good, but it's going to be a little bit more. It's going to be a little steeper here, actually, probably. So it's some kind of curve here going on. So something's going on there. Now it could be like that. I mean, it could also go like this. We don't know. Okay, but it's something differentiable. So, all right. Anyways, it comes from some curve. All right, and if it helps to sketch those points, go for it. Remember, derivatives are rate of change, okay? So derivatives are a rate of change. So when we have a table that has some derivatives, we're going to use that to approximate. So that's an average rate of change, okay? So if we average two rates of change, like how much something is changing between it, that's just the slope, basically, right? Okay, the average rate of change is just the slope. So keep that in mind, all right? And you guys have found slopes since Algebra 1, right? Or pre-Algebra. So keep that in mind. Integrals. Integrals can represent by rectangles or sometimes trapezoids, all right? So we don't need the whole curve to know that, So looking back at like this little sketch, I don't know if this problem asks us for an integral of this here, but all we really need are these points here to be able to make some rectangles, right? And if it helps, draw them out. But we don't need to know what happens to the squiggly red curve, the actual curve of what g of x really is. We don't know. It might do this funny thing, it might not, but still, going through these points here is enough to allow us to make some rectangles for integrals. Integrals are area, right? Okay, so just watch out for using left or right hand. That will tell us which height to choose for the different rectangles. All right, sketch it if it helps. Okay, so good idea is to sketch it if that can help you there. All right. Okay, remember Riemann sum is the name for finding the sum of the areas. Okay, so a Riemann sum is the sum of all the areas, and a Riemann sum, by the way, looks something like this. So when you're writing a Riemann sum, it's always good to write it out. The something like this, the integral. Come on, my pen to work here. All right, the integral. From whatever 0 to 6 or something like that of g of x. Might look something like this. 2 times f of 2 plus 2 times f of 4 plus 2 times f of 6. This would be a right-hand sum. And we could look at the table to find out what these values are, f of 4, f of 2. Notice that the width of each of these intervals is 2. There's the width. And the value of the function would be the height. Okay, I guess actually I should fix that. I put g here, and so if I did g there, I should probably do g in the other one, or I'm going to cheat. There, I'll make that f. But anyways, this kind of expression here, and then we could use the table to go actually find out what those values are. All right, so when demonstrating a Riemann sum, okay, or applying a derivative, or an integral, something like that, make sure you write out the expression. Okay, so again, here's a Riemann sum expression, you know, or if something turns out to be the chain rule, you know, maybe you're showing that the derivative of f of g of x, you know, you're going to run into things like that, and remember, it's the derivative of the outside composed with g of x times the derivative of g of x. That is our chain rule. Okay, so you're going to have situations where the chain rule is going to show up, and if you can put that, if you can state what you're trying to do, that's very likely worth a point. That shows understanding. And then if you mess up in the actual performing of that task, well, you might not get your other point, but that's okay. Couple of last thing to look out for is be ready for the intermediate value theorem. Okay, so IVT, you can abbreviate. IVT is an acceptable abbreviation. Okay, IVT. All right. And then the mean value theorem, MVT. Keep those straight. Okay, IVT is about values, f of x, f of c. Okay, finding a value for f of c. Okay, the mean value theorem is about finding a derivative. So the intermediate value theorem says that if there is, you know, if we have a function, and we've got a point up here, and we've got a point down there for at A and B. Then for some given value here, okay, if this is f of A and this is f of B, well, there's got to be, for some given value, some height in between f of A and f of B, there's got to be some c that if this is continuous at some point, it had to cross through here. So that's for finding f of c, right? There exists an f of c. That's the intermediate value theorem. The mean value theorem was if we have a function and we have a value a and b that looks almost vertical there, but somewhere there is a c, so that that f prime of c exists. F prime of c is the same as the average value. Okay, so that's intermediate value theorem, B. So all right, so look out for those things. Okay, be ready for those when you have these different tables that we're going to look at. You'll see all of these different things. Okay, here, hey, we're looking for a little quotient rule here, right? Okay, they're trying to see if you can use the quotient rule. They're trying to see if you can use the chain rule and recognize that here. All right, so write it out. Write out your chain rule. Write out your quotient rule. Okay, just kind of glancing at these. Here's another table problem here. There must be at least one time where h prime of t equals 2. That's one of those theorems. Is it intermediate or mean value theorem? Think about that one. Okay, so all right, so lots of these things will show up, so hopefully those recommendations will help you be successful at your table problems.